Oh yeah, no problem. Oh, could you push your? Sorry, I see this. No problem. And I also recorded Pierre. So you can also see the recording too. But
Yeah, sorry, I need to go. But the on GitHub, the version is different than the one you showed. So I guess you need to push.
it's here, like this notebook, right?
Yeah, the gradient descent one.
This guy.
Yeah.
Okay, yeah. I will.
Oh no,
It should be. It should be pretty close. Yeah.
I don't
So
understand. Mine look different. I mean, the one I. Okay.
did you use the? Did you use this link? I'll send it on the Slack
Yeah,
or
yeah,
on the Zoom chat again.
yeah. I thought I had the right link.
Yeah.
I
Oh,
never.
for the record too. If you guys if you guys use this right, like feel free to fork. Feel free to do whatever. Right. Like I don't mind. Right. But if you do happen to fork it, just know that I'm constantly updating this specific repo. So you'll have to refresh your fork, right? If you fork in like, let's say you fork today and then like you're like, I changed things up and you're like, oh, I want to see those changes. Your forked version is not going to reflect those changes unless you fetch the information from my fork again, right? And then push it up to your thing. So just kind of know that. But,
How do you do that actually? You fork again?
Not quite. Actually, you know, it's funny. I actually was going to record a video for this for my cohort because they've been asking the same thing.
Yeah.
What you would do. So maybe maybe I'll put a study group out there over the next maybe next week, and I'll show you guys how to do that. And I'll put it. I always put it in the student resources. You guys know how to find the student resources, right? The spreadsheet.
Yeah.
Okay. Yeah. I always try to put it in the whenever I record a video, I'll put it in the student resources.
Done in the terminal, right? Like you do some merge in the terminal to.
Yeah, it's a little complicated. So like if you do, I'll just quickly show real quick. It's that if you have a fork, it's kind of going to be confusing. So I'll just go a whole other stuff. So if I do something like git remote -v, you can see my remotes right here. If you, oops, there we go. So this is like where my folder lives. If you fork it, you will have your own repo, but you'll have to add on the original fork. So you'd have to do a git remote add, and then let's say original, or let's say old fork, and then the repo name of that original fork. Oh my gosh, I keep clicking it by accident. But you would add the name of this, it'd be like HDVS, and then whatever the thing is, like that super long thing. And then what you'd have on there, you would see on the git remote -v, -v, you would see that listed here. And then you would have to do a git fetch of that fork. So let's say my old fork, whatever you named it, whatever that, and you do a git fetch, and then you'd want to do a merge. So you would do a git fetch, and then you would do a git merge on that branch. Technically, a git pull, it's just like that. Although I think you probably could do a git pull. I have to play around with this maybe. I usually do a git fetch first. Git pull basically is a fetch and a merge just put into one place. So when you do a git pull, you are actually pulling everything. Like if I do, technically it says git pull origin to master, right? Like I'm basically I'm pulling from the origin repo, which is this guy right here, into my master branch, which is my local branch, right? And it's gonna fetch that information onto the origin master branch, origin master branch, and then it's gonna merge it onto my local master branch and merge it onto there. So a git fetch is basically just pulling it down without the merge, and then you can do the merge yourself. I think you could probably do a git pull. It's safer to do a git fetch and then git merge, but when you're working with someone else's fork, just because you don't want to accidentally erase your stuff.
Am I on? Oh, yeah.
Yeah.
So when you're merging, you pull in all if I make a change to one of the cells, how does that work with a merge? Like it doesn't change the cell that I changed, but it's going to fetch the cells that I didn't change.
When you're saying just doing a git fetch?
Yeah.
Yeah. When you do a git fetch, basically it's just fetching whatever you're fetching. It's fetching it to that specific branch, which would be like remote, right? Like it's a remote branch, and then this is your master branch, and then you can merge it onto, no problem, William, you have to go. But you can merge that onto then, like, it's like, oh, here's my remote branch. I'm merging it onto my master branch or whatever branch you're working on, and go from there. The thing is that if you made a change here, let's say like you have it synced up, and then you made one extra commit. So this is like slightly ahead. I'll just do like this, like one ahead. When you merge over, it could cause a merge conflict, which then you have to say, oh, okay, you have to fix that kind of stuff. And that's when you get those errors. You have to go into it and say, oh, what did I need to change? Basically, Git is trying to merge it automatically, but if it can't, it gives you a conflict. It says, hey, you got to fix your conflict before, I overwrite this stuff. So yeah, I think my goal is to actually make a little video about this, like a 5-minute video on how to do that with a fork, because for my own cohort, people have asked that too, and I'm like, what?
That would be very useful. Yeah, so it's above my skills in Git, and that happens.
Yeah. It's not.
Sorry, go ahead.
It's not the fun part of the program.
No. So yeah, I think this might be. Here we go. So this is the basic process. I'll try maybe make a little video to just kind of show you guys in the future. Maybe I'll do it this week even. But I'll definitely let your cohort know that since I've talked to you guys. But this is the process, at least. Like essentially what you're doing is that you'll do a git fetch of like that upstream. You have to define the upstream, which is like the original repo. And then what happens is like you can see the git checkout. So this fetch basically is just pulling that information down to that branch. And doing a git checkout and then doing the git merge from your master, right? You're on your master and you're merging the upstream's master onto your master. So the process is actually not too bad, but it helps to understand like what the heck is going on, like versus like just sometimes. Do you guys know XKCD by chance?
Is that the comic?
Yeah, the comic. He has everything that's related to this whole like everything. But this is probably like generally how people feel about Git, including people who've been in like the industry for years. Where basically it's like, hey, it's this really cool thing, but like I don't know what it does. I just do the same exact like commands every single time. That's probably more or less what it is. I just like pointing that out.
Like my machine learning models, no idea, just memorize it and see what happens.
Oh no, this is he has a perfect one of these too. Machine learning. This is pretty much like what you were kind of talking about, Michael, earlier about like saying like, oh, like adjusting things. Like yeah, like pretty much sometimes people treat it just keep adjusting things until it works. So again, if you go through XKCD, Randall Munro, he has so many things for him. Just like, yep, his background's in physics, but he has a pretty good computer science background too. But
awesome.
I feel like I so many times I'm like, oh, I bet XKCD wrote something that's very similar to what this is going on. So yeah. Anyway, little fun stuff. All right. Well, I know I went way over, but I felt like I owed it to you guys, owed it to Eli a little bit to give him a little. Eli was actually my, of course, Eli was actually my kind of like mentor when I first started too, because he kind of like showed me the ropes and stuff like that.
So Eli can code?
Yeah, sometimes. No, no, I like messing with him.
I never seen him code, so.
No, he can code. Yeah, he can code. His style is very different from like my style and stuff like that. But I give him a hard time sometimes. No, but he's great. But yeah, I gave you guys a little extra time since like, it's a little different. Yeah, no problem.
No, it was really good. I liked it.
Cool. Well, thank you. I'll make sure to tell Eli. Tell Eli that, I'm your favorites now, and he'll just.
I will.
All right, guys. Well, I'm gonna let you guys go. And great meeting you guys. And I'll make sure to have the recording out too. I don't know who else is in the cohort, but that way, if you guys want to review it or, if someone missed it or whatnot. And then of course that repo's there too. And I'll let you guys know if I do make that recording about the git fetch thing.
And we can find your, like all your recorded lectures.
Yeah. Yeah. If you go to student resources, I mostly put it there. And then what I just do, cause like, I'm like, if you go to here, just looking over here, if you literally just go to the YouTube channel that I have on here, I just literally put everything public. So, and I have it even, so I have the playlist.
Oh, definitely send us this channel.
Yeah, sure. Here, I'll
Yeah,
send it to you guys right now.
I'll look at that.
Yeah, I'll send it to you guys on Zoom here. But yeah, I organized it too. Just know that you guys are in version 2.1, right? This structure. We had different version changes. I don't know if you're familiar with this over the time. So for example, this, like, you know, I have mod 2 down here. This is going to be a different kind of like different sections. So even though they have the same numbers, they're going to be different. So I would suggest, like, you can definitely go through the channel, like, you know, go for it, whatever, like, you know, whatever helps you guys. I also try to make sure I put all my like videos on the student resources. That way you guys can find it by subject and it's a little bit easier, but that way you can kind of see it by subject. I would say don't worry about the numbers. Like you can see, I try to label all of them. You can see a little bit, just click on a random one. I try to put like the numbers of like what section it belongs to. But if you're looking at older ones, like in the like older than January, look for just the description, like the title. That's going to be easiest.
Yeah, definitely. This is good stuff, man. Good content.
Oh, thanks. I hope it's useful and stuff. And again, it should all be up here too, but feel free. Like sometimes people will subscribe. I don't really care if you subscribe or not. Like I try not to spam you guys with like too many message, like what's it called, like videos and stuff. But as I put them out, if you guys want to, I put them out there and stuff. So, and it's good too, because you can see different instructors. Like I like pointing people to here because people haven't been doing it recently, but especially like in the older videos, you can see there's different instructors that have put in down like different ways. And I just think it's good to just see what other people have done too, because everyone's got a different style.
All right. So your quick 45-second elevator pitch before we let you go. What was the most impactful model and data set that you worked on that like made an impression?
Yeah. Like on like me personally.
Yeah.
Yeah. So I would say, okay, if I'm gonna say impactful, like that's been useful, random forest. Like random forest is the go-to ML model in my opinion. Like if I could only use one ML model, I'd be like random forest all the way because it's quick, it's an interpretable, and like it works for most data sets. And then the data set that I find most interesting was I did a project on American Sign Language recognition and for finger spelling. And so this has always been really fun. I just think it's really cool. Like, I think it's one of those things that like no one really thinks about, or not, I should say no one thinks about, but like, I think it's sometimes abused a little bit in the sense of being like, oh, it really matters. Trying to find a picture real quick. Maybe this is the good pictures. It's an old model I had. There you go.
This is finger spelling. Like,
yeah, so I don't know if you guys are familiar with American Sign Language at all.
Well, yeah, a little bit.
Okay, so American Sign Language is its own language separate from English, and there are things called like classifiers, which are essentially like phonemes in like sign language. So like these are each letter like A, B, C, D, right? And that's finger spelling. And so this is basically just a still image of like someone's signing a letter and stuff like that.
Type thing?
Yeah, it's an image recognition. So trying to figure out like, oh, what letter it is. This one to me is like this has so much potential, and I'm so surprised. I didn't say I'm so surprised, but so many people, like, it's such a great place and such huge value to like the deaf community if we could actually like investigate more about like how do you do recognition, just like speech recognition, but like for like the deaf, like with a capital D, is that I think it's one thing that's I see every once in a while people like show like, oh, we did like, you know, machine translation and stuff. And what kind of makes me kind of annoyed is that it's like, oh, you never talk to the deaf community because they didn't consider like what is involved in actual American Sign Language, because it's not just hands and movements, it's also like facial recognition, like facial expressions. There's a lot of like deepness in ASL. And when I was doing this project, I found how little is actually done like over these past few years, considering how much is like technology we have and how much knowledge we have over the past, you know, few years. The best paper I found was like something from 2010, if I remember this right. And there hasn't been much change in that on like actual research. So
is this a neural network?
yeah, it's a neural network in this case. Yeah. So if you're curious, you can check it out. Like, here's the repo. But
so I understand, like, doing a model on the actual like spelling of sign language, but like you're saying it also incorporates the facial expressions, and you're like modeling.
So I never did that myself, but I was surprised I couldn't find anyone who has actually done that, which is, I say, real American Sign Language. Like, it's less about your finger spelling. Like, I could spell all day like words, but that's not American Sign Language. American Sign Language is much more, even grammatically structured. The syntax is like closer to like Mandarin, from my understanding. Like, I don't know Mandarin, but I know American Sign Language, and it's structured in a different way than English is. And most of the time people focus on recognizing, like, for example, this is mom, this is like dad, like letters A and B, but never talk about like the movement of like, moving something over there, or the facial recognition of saying, like, there's expressions, they're called non-manuals, that that's never put in. Basically, no one's doing real research on like American Sign Language or like other sign languages, because there's other sign languages in the world. Yeah. Real research on this, and there's a few places in there, and even then they're using technology that it's like they're using gloves, they're using multiple cameras, connect cameras, and I'm like, we're doing so much cool things with just literally still images. Like, yeah, definitely someone smart enough out there who could take this and like really do really amazing things with it. And I just amazed no one's seen it. So that's the biggest thing. Like, in my head, I'm just like, if I could go focus on one project, it'd be this guy right here, because I think
that's
so
cool.
many really interesting.
I'm gonna read through that. That's interesting.
That is very cool.
Yeah, if you guys are interested in it, let me know. Definitely message out to me and stuff like that, and I can at least point you in directions if you're interested.
I don't want to keep you up, but what's your take on natural language processing? Is that something that you're interested in and have done some work in at all?
Yeah, that's actually close to like what I really am interested in. This guy right here. NLP stuff is, I like to call it, it's data, it's very dense data, because there's so much information in natural language, and we're just getting to, so natural language is just like speech and stuff like this, like whether it's speech recognition or just literally like looking at words and trying to pull out like specifically like what is like the meaning of this sentence or this paragraph or this paper. And it's a really interesting, like, let's hear it. Like, I think I actually have, you guys are tricking me into staying longer. But I have a little section here in this repo that talks about natural language. If you guys will talk about this in the future module, or future, I think either mod 4 or mod 5. I think it's mod 4. But there's some really interesting things you can pull out from this. And one thing, like, for example, just show like how challenging this problem really is. Like, I like this kind of problem right here. It says the pipe couldn't fit through the hole since it was too big. Well, what does that refer to? It's like, well, you instantly know, oh, it refers to pipe. But that's only because of your context of understanding what a pipe and a hole, like what that means. But if it changed,
it is like, you as a real human being, sometimes you don't know what it is.
Exactly. And there's also ambiguity in natural language. It's really interesting stuff. This is, in my opinion, this is going to be the biggest, like the biggest push forward in like kind of data. Cause like there's like in language, there's so much like context and so much extra stuff in there that it makes, like, I call it like really high density, like information. And we're just starting to be able to scratch the surface where we're able to say, hey, like, can we actually pull information out? And what's cool is that we don't have to do a lot of the stuff that old NLP stuff was having to do with like speech tagging and stuff like this. We can do basically, like, if you guys look at GPT-2, I don't know if you guys are familiar with that. Okay, I see Michael nod. I think it's Dylan frozen, but GPT-2, right? It's just like basically literally just like, hey, we have this thing called a transformer and like this model architecture. It, essentially not a GAN, but like basically a discriminator and stuff like this, and like a transformer. And basically it's like, oh, we have this thing. And all they did basically, well, let's say all they did, but like the big thing they did was just literally feed it like huge amounts of data, like basically as much as they could from the internet as possible onto this model. And it does a really good job of actually generating text that is like, I would say for the most people, if you look at it, you would think a person wrote it. It wouldn't be the best text. You wouldn't think that person may be very smart, but you would think probably like, say, hey, this seems like this could be a person. which has huge amounts of implications, but also extracting information. So like, all right, I'm going to say this one last thing, and then because I think it's the coolest thing. So one thing about GPT-2, like the main idea about it is that you can feed it like saying, hey, start off a sentence, like you write a sentence like in, as a human, and then you say, okay, this model can then, because it's learned a huge amount, go ahead and continue that sentence and write as if you're a person, and it can generate, huge amounts of data. And so people talk about like, oh, what does this really mean? But I think the really interesting thing about it is that one thing that they did for the original paper is, can they have it summarize information? So like the idea there is like, could you, feed like a big area in NLP is like, can you take a text, like an article, give it to your machine learning model and tell me, like, summarize it for me, like, whatever you want. And the way they did this is they didn't actually train it to do this thing, but they figured out a cool like hack, because all it meant to do is just continue on the story. It's kind of like, here's the first part of the story, now you continue it. So what they did, because it was learning off the internet, which is basically learning off its internet culture, they would feed the article, like they would say, okay, here's an article, copy and paste it into GPT-2. And then they would have at the very end, TLDR, too long, didn't read. And it would fill off a TLDR based off of what it had before.
Someone did this on Reddit, or a lot of people did this. I saw this a couple times on like they would basically summarize different subs and posts, and it was like really, and I think YouTube videos too. Yeah.
So summarization in like natural language processing is a big area. Like, how do you, like, if you think about it, like, how do you make sure you summarize the important parts automatically?
I thought I saw this. People were using it to respond to comments too, maybe.
Yeah, that's the biggest concern of GPT-2. Actually, if you guys are curious,
That's how you get all the like internet troll stuff.
Well, that was one concern, but actually, I think a real concern about this, which actually brings up a really good point of this, it's that because of the nature of GPT-2 and other models like discriminators or transformers, is that it relies on trying to trick the computer. Like, it's trying to trick itself and say, what's the best way for to trick myself, and then do a better job of that. And so it's kind of cool is that one of the things it does, what you can use this for, is you can create spam bots that are not detectable by automated sources. Like, let's say Facebook can't detect what is human and what is a bot, essentially. And it's really interesting. I don't know if you guys have seen this. Yeah, you could do some really interesting things. This video GPT-2 and this extra, if you're curious, I think this researcher, what's his name, Miles? Can't remember his name now. Rob Miles. He's an AI researcher. I think he does a really great job of explaining GPT-2. This is about a year old now, but which is crazy to think like, oh, that's old school now. Like, that's old news. But like, I think he does a really great job of explaining, like, why does GPT-2 matter, and like, what does this actually mean in the long run? But yeah. Anyway, all right. Now I'm really gonna go, because I'll keep going on forever.
Dude, thank you so much. Amazing.
Yeah, of course.
Could have talked to you for 6 hours, but
and I enjoy it too. But I do have to go. I'm on the West Coast, so it's like dinner time now. Yeah. All right. Well, good talking to you guys,
right,
and great meeting
man.
you. And I'll let you guys have the recording too. But feel free to message me too if you guys have questions and stuff.
appreciate that.
And I'll talk shit to Eli for you.
Yeah. All right. Take care, everyone.
Thanks.
Bye. All right. Thanks, Victor.